What if there is a planet in our solar system that we have never seen? Not a distant world beyond Neptune. Not a dwarf planet hidden in the Kuiper Belt. A full-sized planet, potentially the size of Earth, orbiting the Sun at exactly the same distance we do, always behind the Sun, always hidden, always just beyond our view. It sounds impossible. It sounds like science fiction. But the idea is much older than science fiction. More than 2,400 years ago, Greek philosophers proposed that such a world might exist. They called it Antichthon, the counter-Earth. What makes the idea so intriguing is not that they were right. They almost certainly were not. It is that modern orbital mechanics cannot dismiss the concept as easily as you might expect. For more than 2 millennia, people have wondered whether something could remain hidden on the far side of the Sun. Even today, that question has not received a completely definitive answer. The idea begins in the 5th century before Christ. The Greek philosopher Philolaus, a member of the Pythagorean school, proposed a model of the cosmos unlike anything most people believed at the time. Instead of placing Earth at the center of everything, he imagined a central fire. Earth orbited that fire, and directly opposite Earth traveled another world. He called it Antichthon, the counter-Earth. According to his model, the second world remained permanently hidden because the central fire always blocked it from view. Philolaus was wrong about the structure of the solar system. There is no central fire. Earth orbits the Sun. His model belonged more to philosophy than to astronomy. But one part of the idea turned out to be surprisingly resilient. A planet sharing Earth's orbit could, under the right conditions, remain hidden behind the Sun. The mechanism itself was never physically impossible, only the model surrounding it was. That brings us to modern orbital mechanics. There's a location known as the L3 Lagrange point. It lies directly opposite Earth on the far side of the Sun. From Earth's perspective, the Sun permanently blocks our view of that region. Ground-based telescopes cannot see through the Sun. For most of human history, humanity had no practical way to observe what lay there. For centuries, the counter-Earth remained impossible to confirm, not because the idea was especially convincing, because there was simply no way to check. Sometimes an idea survives, not because the evidence supports it, but because the evidence cannot yet reach it. That brings us to the physics. This is the part that surprises most people. The idea is not built entirely on ancient philosophy. It also involves real orbital mechanics. Whenever two massive objects orbit one another, such as the Sun and Earth, gravity creates 5 special locations where the forces balance in unusual ways. These are known as Lagrange points: L1, L2, L3, L4, and L5. They are not hypothetical. Space agencies use them today. The James Webb Space Telescope operates near the Sun-Earth L2 point, roughly 1.5 million kilometers beyond Earth. It remains there because the mathematics of gravity make that location especially useful. The point that concerns us tonight is L3. It lies on the opposite side of the Sun, approximately 300 million kilometers from Earth. If an object occupied that position, it would orbit the Sun at exactly the same distance and nearly the same speed as Earth. From our perspective, it would always remain behind the Sun. It would never appear in the night sky. It would never pass in front of the Sun. As long as it remained at L3, it would stay hidden from direct observation from Earth. That sounds almost perfect. There is just one problem. L3 is not stable. Physicists describe it as an unstable equilibrium. Imagine balancing a ball on the top of a hill. If the ball sits perfectly still, it remains balanced. The slightest push changes everything. Gravity takes over. The ball rolls away. L3 behaves much the same way. Small gravitational influences gradually disturb anything placed there. The pull of Jupiter. The influence of Venus. Passing asteroids. Tiny orbital changes accumulating over immense spans of time. Eventually, an object at L3 should drift away from its position. Over thousands, or perhaps millions of years. It would gradually move far enough that observers on Earth could eventually detect it. According to our current understanding of celestial mechanics, a large planet should not remain hidden there for the entire age of the solar system. That does not mean a counter-Earth is impossible. It means one could not remain there indefinitely through natural orbital mechanics alone. A temporary object could occupy L3. A permanently hidden Earth-sized world becomes much more difficult to explain, unless something were actively maintaining its position. That final possibility is highly speculative. There is no evidence that anything is doing so. But it naturally raises the next question. Have we actually looked carefully enough to rule the idea out? That brings us to the obvious question. Have we actually looked? The answer is yes, but perhaps not as completely as many people assume. The first meaningful opportunity came during the 1970s. On its journey toward Mercury, NASA's Mariner 10 mission spacecraft was positioned to observe part of the region around the L3 point. It found no planet, no large object, nothing that resembled a hidden Earth. That sounds conclusive, but there is an important detail. Mariner 10 was never designed to search for a counter-Earth. Its primary mission was to study Mercury and Venus. Any observations of the L3 region were secondary, limited by the spacecraft's instruments, trajectory, and original mission objectives. A much more capable opportunity arrived in 2006 with NASA's Stereo mission. For the first time, two spacecraft observed the Sun from positions that eventually allowed scientists to view regions normally hidden from Earth. The mission surveyed the space around the L3 region. No Earth-sized planet was found. For most astronomers, that result settles the question. And it is an important result. But there is another detail worth remembering. Stereo was built to study the Sun, solar flares, coronal mass ejections, the solar wind. Its instruments were optimized for solar science, not for detecting dark planetary bodies against intense solar glare at extreme distances. That distinction does not invalidate the mission. It simply explains what the mission was designed to accomplish. Looking behind the Sun is not quite the same thing as conducting a dedicated search for hidden planets. There is another part of Earth's orbit that receives surprisingly little attention. The L4 and L5 Lagrange points. Unlike L3, these locations are gravitationally stable. Objects placed there tend to remain there naturally. Jupiter has thousands of Trojan asteroids occupying its own L4 and L5 regions. Earth has one confirmed Trojan asteroid. It is known as 2010 TK7. It was not discovered until 2010. That discovery reminds us of something important. Even within Earth's own orbital neighborhood, there are regions we have only recently begun exploring carefully. The first confirmed Trojan companion to our planet was identified little more than a decade ago. There may be others still waiting to be found. Not hidden planets. Almost certainly not. But smaller companions that have escaped detection because few missions have searched specifically for them. That realization changes the conversation. The question is no longer whether a hidden Earth-sized planet almost certainly exists. Current evidence argues strongly against that idea. The more interesting question is much simpler. How thoroughly have we explored every corner of our own orbital neighborhood? The honest answer is that some regions have received far more attention than others. And history has shown that even close to home, space can still surprise us. Now step back from the details for a moment. The idea of a hidden counter-Earth is almost certainly not correct. The evidence we have today strongly argues against the existence of an Earth-sized planet permanently concealed at the L3 Lagrange point. The orbital instability of L3, the observations made by missions such as Mariner 10 and Stereo, the gravitational influence such a world would exert on the rest of the solar system. Taken together, they make the hypothesis extremely unlikely. Science should follow the evidence. Right now, the evidence does not support a hidden planet. But that is not the most interesting part of the story. The most interesting part is what the idea reveals about us. We have mapped the surface of Mars with extraordinary precision. We have photographed Pluto. We have landed spacecraft on comets. We have discovered thousands of planets orbiting distant stars. Yet one region of our own solar system remained hidden from direct observation for most of human history, simply because the sun stood in the way. That was never a technological failure. It was a consequence of geometry. Sometimes the greatest blind spots are created not by distance, but by perspective. The counter-Earth reminds us of something science has taught us repeatedly. Ideas should not be accepted simply because they are ancient. Neither should they be dismissed simply because they sound unusual. They should be tested. Some survive. Most do not. That process is exactly what makes science reliable. The counter-Earth is valuable not because it is probably real. It is valuable because it forced generations of astronomers to ask better questions about orbital mechanics, observation, and the limits of what we can actually see. If questions like this fascinate you, consider subscribing. Every week we explore another mystery where established science, historical ideas, and unresolved questions meet. Sometimes the evidence strengthens the conventional explanation. Sometimes it reveals something unexpected. Either way, the search itself is worth following. Tonight, somewhere beyond the sun, there is no reason to expect an undiscovered Earth waiting in the darkness. But there is something else. A reminder that even in our own cosmic neighborhood, there are places humanity has only recently begun to explore carefully. Every generation assumes it has already found the obvious. History suggests otherwise. The greatest discoveries are often not hidden because they are far away. They remain hidden because no one thought to look from the right angle. Perhaps that is the real lesson behind the counter-Earth. Not that a planet has been hiding behind the sun for thousands of years, but that curiosity begins wherever certainty ends.